So what does a strain gauge look like? So let's look at the construction of strain gauge. And it's pretty simple. We have a thin resistor. Okay, I'll put in the very thin in there. We'll come to that in a minute. We've got a foil on some sort of non-conductive backing. Somewhere around 25 to 70 microns. It does depend on the actual gauge type. Some are thinner, some are thicker. This will be considered a typical range. These sensors are bonded to a structure using some process that we will review very briefly. And this will accurately follow the structure's deformations, and it will give you a resistance change as the strain changes. Just a bit more of a close-up here, and there's a few more bits of terminology, and I don't really have time to go through all of these. I've been timing this, but you can look at this at your leisure at a later time. This just shows another close-up with some of the terminology. We have here the gauge length. So when we talk about a 6mm strain gauge, we mean that the length inside these end loops here is 6mm. And the strain measures average strain in the grid, and it measures strain in the direction of the grid lines. And that's why we have these very distinctive alignment marks, so we can position the gauge accurately to take the measurement that we wish to take. When we say very thin, let's define the two things it's made of. Well, the foil, we talk about 5 microns, although we are rolling foil down to 2.5 microns on occasion. And the matrix, typically 25 microns. It can be thinner with some strain gauges, thicker on others. But we are talking about a device that is something like half the thickness of a human hair overall. So a typical human hair is around 50 microns. The foil is 1/10 of that, and the matrix is half of that. So it's a very, very thin sensor. One thing to note, by the way, this is a traditional strain gauge. Notice that they have this serpentine pattern with the end loops, and we'll contrast that to what we call the advanced sensor in a little while. Now this strain gauge is a photo etch device. So we take a foil, bond it to a carrier, and then we photo etch a pattern. So they can be photo etched in many different patterns. Now I've been saying for 30 years that we do 250,000 different types of strain gauge, and we produce new patterns, custom patterns every week. So it's certainly well over now 250,000 different patterns. We can have what's called a single linear strain gauge, designed to measure strain in one direction. We can measure torsion or shear, so you might want to do convert a drive shaft to torsion measurement for power output. If you want to measure a linear strain gauge, you need to know which direction to put the gauge, whereas if you use a through rose etch, you can resolve by maths the actual principal magnitudes and directions. So if you don't know direction, a through rosette is ideal. We have T-rosettes, great for material property testing, that I'll mention a bit later on. And we also do residual stress gauges, where you drill a hole and measure the change of strain to the relief of stress, and then you can calculate the stress that was in the part before you drilled the hole. We also do a range of weldable strain gauges that we'll mention later, and the grid sizes can be anywhere from 0.2 millimeters up to over 100 millimeters. This is because a strain gauge is an averaging device. If we're working on concrete, we want to get an average strain in the concrete and not a local strain on or near one of the lumps of aggregate.